Great. Welcome, everybody. Hope you can hear me loud and clear. Welcome to our live stream, AI, IoT Edge Applications, Insights and Trends. Okay. And I'm very pleased to have everybody here today. And I'm extra pleased to be joined by Martin Croome from GreenWaves Technologies. And I'm going to introduce or ask Martin to introduce himself in a little while. First of all, let's do a little bit of housekeeping. We want to make this an interactive session, so we're very happy to take some questions. If you want to do that, you'll see via the Zoom panel, you'll see at the bottom there should be a button that says Q&A. You can type your questions in, and we'll take them later on in the session. Also, this is being recorded. So we will be putting this up on YouTube, our YouTube channel, which is the Smart Building series. And if you want to share that with your colleagues, obviously, please go ahead and do that. It should be up later on today. So yeah, let's get started. So we're talking about AI, IoT edge applications today and their impact on smart buildings and the built environment. And as part of the research that we've been doing over the last couple of months, we've been looking specifically at the impact of IoT on buildings. And Martin is going to give an in-depth presentation in a while about how some of the technical aspects are really affecting performance. And you know, Martin works for a fabless semiconductor startup. And they have a really interesting, insightful view on how the technologies are moving forward. From my perspective, you know, obviously I run an analyst company, and we take a sort of, obviously a broader view of it, and not just looking at the actual technologies themselves, but also the barriers and drivers to technology adoption. And you can see here on the screen, this is a graphic that we've produced as part of our research into this area. And, you know, obviously, what do we think that the big impacts of the IoT can be on buildings, commercial buildings? What we're trying to do is to move buildings from level one, where, you know, we use technology for optimizing operational efficiency, move them through to level two, and finally to level three about innovation and differentiation. And what do we mean by that? Well, you can see along the top, we're talking about moving from not just from an integration point of view from these different systems, not just having standalone siloed systems, but moving them to much more integrated and holistic system within the buildings. And from an intelligence point of view, moving it from not just about rules-based analytics, making decisions that based on whatever we program it to do, but ultimately to move our buildings to have more intelligence. And that's really, you know, in our opinion, what the IoT is all about, what we're trying to do here. And I think this is a graphic that anyone who's familiar with our work will be used to and seeing before. I mean, and I talked there just before about all this different siloed states that we have in buildings. And you can see here a representation of all these different systems. A lot of them don't talk to each other. The IoT, one of the big things about that is about bringing systems together, integrating them. And that's one of the big benefits of the technology, that we can use data, let's say from an access control system, to help us understand, for example, occupancy and other aspects of creating more efficiency in buildings. So I'm now going to introduce Martin. Martin Croome is VP of Marketing, as I said, at GreenWaves Technologies. Really, really interesting company based in France. It's a startup, well-funded startup that is producing semiconductors in this space. So Martin, very happy to have you today.
Thanks, James. Very happy to be here.
Great stuff.
So yeah, let me go a little bit more detail of who GreenWaves is. As James said, we're based in France. We make chips, well, we design chips, and then they're produced by our partners. We have about 42 people, so relatively small, based in Grenoble, but we have offices in China and Italy, and pretty much a global sales footprint. Our business is really kind of split 50-50 between, I would say, hearables, primarily wearables, and then IoT. And in IoT, there's a portion of that business that's in building. And I think it's not too conceited to say that we're pretty well recognized as one of the leaders in embedding intelligence into highly energy constrained devices. And that's really where our processes are focused. They're focused on embedding AI and digital signal processing into tiny devices that either need to last for a day on a microscopic battery or for years in a sensor like a building sensor, and doing this very significant processing that we need to do for doing AI in that. You can see our latest product on the bottom, which is SCAP9, which is a tiny little chip. We already have one product in the market, which is actually in some building products, and I'm going to show you one a little bit later in the presentation. Could I have the next slide, please?
Yep.
So, what does AI, and I try to kind of make this very high level, what does AI kind of mean, mostly mean in the IoT space? And, we have these things, deep neural networks, which we can really, for the purposes of this presentation, just think of it as a kind of black box. And really a black box taking in some kind of high dimensional features like photos of different things, or some time series information, which can be things like movements and sounds and so on and so forth. And really what that deep neural network is doing is then kind of compressing that really quite large amount of data down to a few things, down to some kind of metadata, which is much more interesting. Like, is it a person? Where is that person in a building? Is the person or the object in some kind of unexpected state? This is particularly the case in kind of detecting, in the building context, is an HVAC system, for example, vibrating in a way which is not normal. This is kind of detection of anomaly. And then something which is very, I would say, very popular at the moment, or very much in the news at the moment, is neural networks that are not just kind of, doing these kind of classification steps, which are very, in a sense, binary steps. Is it a dog? Is it a person? It's a decision step. There's also neural networks now, and very much, in the news at the moment is ChatGPT, which are actually generating stuff. So it's taking an input feature and somehow transforming it into something new. And where we work in that area mostly is doing things like generating a filter that's going to remove noise from a noisy voice. So cleaning noise from a voice, something of that sort. Can I have the next slide, please?
Yep, it's up.
So why do we do this inside sensors in buildings? Why not do this just all in the cloud? Obviously, there's a large proportion of AI which is actually executed in the cloud, and there are good reasons to do it in the cloud. But some of the reasons which require us to start doing it on the device really fundamentally link back to the fact that this data is actually quite a lot of data. If you take a photo, that's a lot of information, and most of that information is irrelevant. You take the photo when there's no one there and you're trying to see if there's someone there. All of the information in that photo is irrelevant, and you really don't want to transport all of that irrelevant information. You want to get down to the core of that information, which is there is something that I'm interested in that data, and then potentially maybe transport some segment of that image up to some system, but only when there's something interesting there. So the cost of transporting data is quite significant there. Second cost, which actually comes very often in building systems, is the cost of installation. Installing a device inside a building, if you need to power it, if you need to provide a high capacity network link to it, can be quite expensive, because just pulling a cable can be quite an expensive thing there. Then there's a kind of back-end capacity side of this, pulling images back into a centralized system, where you have to process all of those. If you start getting a significant amount of those cameras, it starts becoming a very difficult problem from a data center perspective. And again, as I said, most of that data is actually irrelevant. And then there's also obviously an element of security. When you start pulling things from cameras, people get sensitive about the security aspects of that. And then finally, in terms of capability, sometimes what you want to do requires a very fast action close to the device. And there are certain use cases where this happens. And then, this time to action, this latency that you need to achieve is not achievable if you send all of this data back to some centralized system and then have to get it down to the device again. So all of this kind of comes back to two key points of cost and feasibility within the use case that you're developing. Next slide, please. So what are the key challenges in developing these kind of AI, embedded AI functionalities inside products which are actually inside buildings or actually deployed outside in places? Well, one could imagine, that it's difficult to do all of the compression of getting some of these things to run in a very low power in a very small device. Actually, probably the biggest thing is the bit that I put in the middle here. But even before, just having a clear idea of what you want to achieve with the AI capabilities and kind of bringing an imaginative understanding of the problems that you have inside a building, combined with actually the capabilities of modern systems, using, for example, our chips, kind of bringing those two things together is your first challenge. Then once you've got that idea, that use case, then getting a trained AI model, that's what we call, deep neural network models, that gives you adequate performance in real life situations before you've even tried to put it into a sensor, is probably the biggest challenge. And there's two kind of things that need to kind of come together for that. One is some kind of reasonable idea of what is possible. We do see people coming with ideas where they want to do something, but even, a human isn't capable of doing what they want to do. And the information just isn't there in the data for them to be able to do what they want to do. And the second thing is obviously the data. These deep neural networks, they're trained on literally thousands or tens of thousands, even hundreds of thousands of possible inputs and expected outputs. And that data is difficult to collect, and very, very important. I can give little examples of, for example, we have a people counting device, which I'm going to talk about. If you had, hot sun shining through a window onto a floor, that's going to have an effect on a camera that's looking down, particularly infrared camera, which is what we're using. So that kind of data to allow you to train the model to get past that is very important. After you've done all of that, you've got your trained model, it's doing what you want to do, then getting it to run at a reasonable price performance point for your application is obviously the next step, but that's really an engineering step. And generally, we can help a lot with that engineering step. But really having a clear idea of what you want to do, and a trained model is the first thing. Next slide. So this is an example of a product that was developed with our first generation product, GAP8. It's from a company called Contact.io. It's an infrared people counter. It can be installed in a room, in rooms in buildings. And what does it get used for? Well, things like you can see an image on the right hand side of the people that it's seeing, and the green boxes which are put there is actually done by the AI model inside the product. So that's actually done inside the product. It's battery operated, so you can just stick it up on the ceiling, and has a 4-year battery life, waking up every minute or so. What can this be used for? Well, hot desking, counting people in meeting rooms to make sure the meeting rooms are being properly used, smart cleaning applications, crowding inside zones, like, for example, cafeteria, encouraging people to come when the cafeteria is empty, not when it's full. And all of these, there's a ton of different business cases that are enabled by having this kind of device that can count and locate people inside space. And this, obviously, this product integrates also other things like temperature sensing and environmental monitoring of various different types. Next slide, please. But I think one of the things that's really important in this is to actually realize that the capabilities that we have now on really, really low power devices are really quite extraordinary. We can do this kind of boxing and people spotting either in IR or visible camera images. And we're doing that detection at hundreds of microjoules. So this is really very, very low power, and it enables battery lives that are very, very long. And we can also run quite complex multi-stage pipelines. So this is an example of doing license plate recognition, which is a combination first of actually spotting where is a license plate in an image, then separating the numbers and letters inside that license plate out into individual numbers and letters, and then finally recognizing. And that is quite a complex pipeline. Again, something that we can do, on milliwatts of power continuously, millijoules or microjoules in terms of single frames. And as usual, kind of combining this knowledge of what is possible with a really deep understanding of the problems facing a certain industry like buildings is really what is the barrier to people kind of coming up with. So kind of our biggest competitor in a way is ignorance. And that's what we have to overcome at this point in the marketplace. Next slide, please. So finally, where do I think this is going? And obviously there's kind of crystal ball stuff, but I believe that we're going to see this kind of intelligence becoming more pervasive and kind of getting embedded into products in a way which is much more hidden, in the sense that you won't really have to bother about it so much as you do at the moment. And that's kind of going to happen both at the component level, where some intelligence gets kind of very horizontal, I would say, demand intelligence gets embedded into sensors. So you can easily imagine that many people would want a microphone to be able to spot a human voice. And from an energy efficiency perspective, it's probably more efficient to actually do that spotting inside the microphone component itself. So you keep in an analog domain, or even if you're in a MEMS kind of domain, you're in an analog domain, and you can do all of that stuff inside the microphone. And then there's going to be the intelligence kind of embedded into smarter products. So products adapting to their environment. Sound, I'm giving an example here which isn't very building related, but in the earbud relation, when you wear an earbud, having the sound adapt to your particular environment where you're listening, having the voice pickup that's being done, adapting to the particular place where you're in, be it a noisy cafe or whatever, and cleaning out your voice. That these are kind of things which will be in the next generation of products, which will be very, very adaptive and responsive to environment. So that was my little view of the future.
That was fantastic. Thank you, Martin. That was awesome. And we've got your contact details there for GreenWaves Technologies on the slide. Guys, we have a few minutes left. So if you have some questions for Martin, perhaps around his vision of, what's going on in the future, or even, some of the use cases that he mentioned in the presentation. So I think my first question Martin, would be, you talked about actually the, your own development cycle, Gap 8, now 9. I believe you're also working on some updates as well. Can you tell us a little bit about that and what kind of extra functionality that will bring?
Yeah, so Gap 8 was really our first generation product, and it was really focused on IoT. And obviously as a startup, when we taped out that product, which tape out means when we kind of sent it to our fabricator to get it made, we were 10 people, so it was a pretty small company. We've grown a lot since then, and our markets have expanded. So Gap 9 brings a lot more capability in terms of both power consumption. So that product that I mentioned, the Contact IO product, which is done with Gap 8, with a battery life of 4 years with a few AA batteries. GAP 9 is about 10 times more capable and about 6 times more energy efficient. And so it can handle much bigger problems. It also brings a lot of ability in the audio domain, and this is perhaps an area which is quite interesting from a building perspective. So doing things like sound detection, but also sound localization, multi-microphone, sound localization, identifying not just what a sound is, but where it came from. So those are kind of functionalities that are in that product.
I actually think audio gets ignored a little bit in buildings. Not so much from the AV perspective, but like for example, in a open office, a lot of people complain about noise pollution and not being able to concentrate because of that. So yeah, interesting.
Yeah, it may be there is some technology that is now arriving in cars, which are essentially audio bubbles, where it's using beamforming. This may be difficult to do inside such a large space as a building, but interestingly, in cars, these audio bubbles are using beamforming of speakers to actually actively cancel noise close to someone's ear in multiple domains inside the car. Now, it would be amazing if that kind of technology could get into a building, but Absolutely. I think it may be difficult to do in a big room.
Yeah. I think we have a question. Let's take one from the audience.
Okay, so considering the low power consumption, what is the communication protocol? Is it an open API? From Robert.
Okay, so in the case of Contact, they are using Bluetooth Low Energy. They're using the Bluetooth Low Energy infrastructure to Cisco routers. So they're actually using the router IoT connection to actually upload. And we've seen, I would say, kind of two technologies being predominantly used in the IoT space. One is Bluetooth Low Energy in some kind of mesh form or something of that sort, and the second one is LoRa. Now I know that in the building space as well, there's a certain amount of Zigbee that goes on, and all of these would be compatible with it. With this kind of product, which kind of wakes up, takes a photo, does some kind of operation, decides if there's something interesting, and then forwards information if there is.
Mm-hmm. Yeah, and as I think we can just bring up that slide again. I think it's really interesting because it's doing that categorization or on the edge, right? We're not sending any information
absolutely.
here.
The image doesn't go anywhere. It doesn't go off the device. So the image stays on the device. The analysis of the image is done on the device. So the output of that analysis is essentially the coordinates of each box and the size of each box. And then what you do with those boxes is up to you. So you could count them and you just send the count. Or we have some technology that we use to allow stitching offline. So you can send the box locations and we can stitch the box locations back together if you've got multiple ones of these sensors in a space. So then that gives you a kind of an idea of location of each person. You can also do, kind of just a crowding kind of, there's a lot or not a lot. And also obviously, that's just one application using visible light. You can do a lot more. For example, doing things like signs of life. So if there's a coat over the back of a chair, detecting that coat and seeing that actually that chair is occupied because someone's left that coat there. Maybe they're not there at the moment, but they're going to be there, or their PC is in front of their chair, or whatever.
That is a really
there's a lot of clever things you can do.
Interesting use case, I think, it's because I spoke about this with someone who runs a business like this, and they said, often in an office environment, someone will come in and have that hot desk and sort of camp on it, put their stuff down, right, and then go off and go to another meeting room or something. And
if you have something which is just focused on people detection, just detecting that the person is sitting in front of the desk, then that won't capture that.
Exactly.
So signs of life is kind of one of the things which is important there.
Yeah, and obviously this kind of applications of sensing networks that are that are low energy, that can run off batteries. I mean, there's so many applications, I think, in buildings, especially because of a lot of retrofitting equipment can be expensive. You talked about the cost side of it, and also I would say in certain buildings as well, like it's not really possible to do, to pull wires into a lot of buildings. So I think, you're
Yeah.
doing this, it opens up a lot more buildings for us to make them smart.
Yeah, I think one of the other things we've seen with this pulling wires thing is that often some of these services are actually offered by a service company. And so they're coming in and installing their sensors maybe on a leasing basis or, as a subscription service and so on and so forth. So they can't pull wires, it's not really, they would have to negotiate with the building owner, and then that can be complicated as well because the building owner is not necessarily the person who's in the building.
Mm-hmm.
And then they've got to, pull these wires, and then you've got the networking aspect of that as well. So it gets very, very complicated.
Mm-hmm.
So just having something that's battery operated, you can stick on the ceiling, with its own network infrastructure is really useful.
Yeah, exactly. Very powerful. We're coming to the end of the session now. So anyone who has a final question, if you do, please ask it now. I guess Martin, like if someone's interested in more information about the company, and obviously we've got the website up there, but is there some other forms of communication they can get hold of you guys?
Yeah, absolutely. On the website, there's a contact page, so you can get to us through that, and that will lead you to the appropriate person to be talking to in your region. And there's a lot of content on the website about what we're doing, and I'd also, if people are really interested in this kind of low-powered AI area, then I'd really encourage you to go to tinyml.org, which is a organization which groups a lot of actors in that area of doing machine learning on very small and very low powered things.
Okay, that's
and there's
interesting.
a ton of videos on there, YouTube, which are more technical, but look into this market area.
Great, thanks for that. Yeah, I'm sure that sounds really interesting. Well, I think that's we can wrap up there. Look, Martin, thank you so much for your time.
Thank you.
Really appreciate it, and it's such a fascinating subject and really ties in nicely with the research that we've been doing. So glad to have you on.
Thank you. Thanks for the invite.
Of course, and obviously thanks to everybody who's tuned in. I hope you found that useful. Just to finish off and say, we are recording the session, and we'll make sure that that recording goes up, and you will get, I think, an email tomorrow with the link to find that, and please share it with your colleagues. So thanks a lot. Bye, everybody.
Thank you.